Since the beginning of the Industrial Revolution, humanity has developed a quiet obsession with building ever larger machines. For centuries, progress was measured not only by efficiency, but by size, power, and the ability to dominate nature on a massive scale. The bigger the machine, the stronger the illusion of technological superiority, economic strength, and total control over natural resources. In the 20th century, this mindset reached its peak. Industrialized nations invested billions into monumental projects, massive dams, nuclear power plants, endless factories, and machines so large they seemed to defy logic itself. The belief was simple and dangerously appealing. If something works, making it bigger will make it better, more productive, more profitable, more permanent. Coal played a central role in this worldview. It was the fuel that powered factories, heated cities, and sustained entire national economies. In Europe especially, coal was not just an energy source, it was a strategic asset. Governments, engineers, and corporations believed that securing long-term access to coal meant securing economic stability for generations to come. This belief gave rise to mining megamachines. These were not ordinary tools, but complete industrial systems mounted on rails. Each one required its own infrastructure, long-term planning, and enormous financial investment. They were not designed to operate for a few years, but for decades. They represented a promise that the economic model they supported would never fail. This is where the story begins to grow unsettling. When an entire economy is built around massive, inflexible structures, it becomes slow to adapt and extremely vulnerable to change. The larger the project, the harder it is to adjust. The more money invested, the stronger the resistance to admitting that the system itself may be flawed. It was within this context that one of the largest land-based machines ever created came into existence, Bagger, Tula 93. It was not designed as an experiment or an engineering curiosity. It was conceived as a definitive solution, a machine capable of removing Earth on a scale never before imagined, feeding an energy system that appeared unstoppable and eternal. Before moving forward, this is the moment to pause. If you enjoy real stories about massive projects, extreme human decisions, and the unexpected consequences of progress, this is the time to subscribe to the Wrong Project channel. And leave a comment sharing your thoughts on industrial megaprojects. Are they symbols of progress or of human arrogance? Your perspective matters here, because understanding Bagger 293 is not just about understanding a machine. It is about understanding a mindset, a time when the world believed that limitless growth was not only possible, but unavoidable. And as this story unfolds, we will see that this belief came at a far greater cost than anyone anticipated. Bagger 293 was not the result of an isolated whim or an engineering curiosity. It was born from what was perceived as an urgent necessity within the German mining industry. For decades, the country relied heavily on open-pit coal mining, particularly lignite, a type of coal that is abundant but has low energy efficiency and a severe environmental impact. To make this resource economically viable, it had to be extracted in massive quantities, continuously and without interruption. It was within this context that engineers and industrial planners began to envision a radical solution. A machine that would not simply dig, but operate almost like a moving industrial city. The idea was simple on paper, but extreme in execution. Instead of relying on multiple smaller machines, vulnerable to breakdowns and inefficiencies, why not build a single colossal structure capable of operating day and night, removing Earth at an unprecedented scale? The construction of Bagger 293 involved multiple companies, thousands of workers, and years of planning. Every component was designed for extreme-scale operation. Its bucket wheel, The heart of the machine was engineered to rotate continuously, cutting into the ground and transferring material onto internal conveyor belts that ran through the entire structure. Nothing about it was simple. Nothing was light. Nothing could be easily replaced. The final result was a machine over 90 meters tall and hundreds of meters long. Its weight exceeded tens of thousands of tons. To move, it did not rely on conventional wheels, but on massive track systems that distributed its weight to prevent the ground beneath it from collapsing. Even so, every movement required careful planning and a constant supply of electrical power. One critical detail is that Bagger 293 did not have its own engine in the traditional sense. It depended entirely on external electricity, connected directly to the power grid. This meant that operating the machine required more than simply turning it on. An entire energy infrastructure had to remain stable and uninterrupted. The machine was not autonomous. It was embedded within a highly complex industrial ecosystem. From an engineering perspective, this was an extraordinary achievement. Bagger 293 performed exactly as designed. It removed unimaginable volumes of earth with consistency and efficiency. Technically speaking, it was a success, a triumph of human capability to transform abstract ideas into colossal physical reality. And yet, this is where the trap begins. When something is built on such an immense scale, any miscalculation ceases to be minor. Any economic shift becomes unmanageable. Engineering had conquered the technical challenge, but it was beginning to overlook a crucial factor. The world surrounding the machine does not remain static. Bagger 293 was built for a future that seemed guaranteed, but was already quietly unraveling. And as we will see in the next parts, when reality changes, giant machines cannot adapt as easily as smaller ideas can. At first glance, Bagger 293 appeared to be the perfect solution to the challenges of modern mining. Its enormous scale created an automatic sense of efficiency. The logic seemed unquestionable. A single massive machine operating continuously would replace dozens of smaller units, reduce operational costs, and deliver unmatched productivity. On paper, the numbers were impressive. In reality, the story was far more complex. The efficiency of a mega machine like Bagger 293 cannot be measured solely by how much earth it removes per hour. Every ton excavated carried hidden costs that rarely appeared in early projections. Energy consumption was massive and constant. Any interruption in power supply resulted in costly and prolonged shutdowns. Unlike smaller machines that can be turned off or replaced quickly, Bagger 293 required absolute stability. Maintenance was another monumental challenge. Every component was custom-built specifically for that structure. There were no off-the-shelf replacement parts. When something failed, repairs did not involve just technicians, but entire teams, specialized cranes, and weeks of planning. A minor mechanical issue could quickly escalate into a multi-million-dollar loss. Operational rigidity was another critical factor. Bagger 293 could not easily change roles, be relocated quickly, or adapt to new demands. It was designed for a single purpose, extracting coal in open pit mines prepared specifically for its operation. If market conditions shifted, demand dropped, or new regulations emerged, the machine had no ability to reinvent itself. This is a central point in the story of Bagger 293. The promise of total efficiency masked an extreme dependence on a very specific economic scenario. As long as coal prices remained stable and energy consumption continued to grow, the model worked. But economies are not predictable machines. They fluctuate, adapt, and sometimes collapse. Over time, alternative energy sources began to gain ground. The environmental cost of coal became impossible to ignore. Political pressure, international agreements, and shifts in public behavior started to question the long-term viability of heavy mining. What was once celebrated as progress increasingly came to be seen as a problem. In this new reality, scale, once an advantage, became a burden. Bagger 293 could not simply be shut down without severe financial consequences. Every idle hour meant significant losses. Every attempt to adapt required even greater investment. The machine had become too big to fail, and for that very reason, dangerously fragile. The illusion of efficiency was collapsing. Gigantism, once perceived as a definitive solution, revealed itself as a risky bet in a world that changes too quickly. Bagger 293 continued to operate, but the system surrounding it was showing clear signs of exhaustion. And at this point, the story stops being just about engineering and becomes about human decisions. Because when something is built too big to stop, the cost of failure is no longer technical. It becomes economic, social, and environmental. Behind the imposing presence of Bagger 293 lies a reality that rarely appears in promotional images or technical reports. The deep human and environmental impact caused by machines of this magnitude. Open-pit mining, required for Bagger 293 to operate, does not merely transform landscapes, it completely redefines territories, altering the lives of entire communities and leaving scars that last for generations. For the machine to advance, entire villages had to be erased from the map. Homes, churches, schools, and cemeteries were relocated or simply demolished. Families who had lived in the same regions for decades, sometimes centuries, were forced to abandon their roots in the name of an energy model deemed essential. While financial compensation was often provided, the cultural and psychological cost of displacement was never fully measured. The natural environment suffered irreversible changes as well. Forests were cleared, river courses redirected, and original soil layers completely removed. Bagger 293 does not excavate coal alone. It removes everything above it. Fertile soil, entire ecosystems, and natural habitats disappear to make way for massive craters. Even after mining operations cease, environmental recovery is slow, expensive, and often incomplete. Another critical issue is the pollution associated with the coal extracted by such megamachines. Lignite, in particular, is among the most polluting fossil fuels in existence. When burned, it releases vast amounts of carbon dioxide, toxic particles, and other pollutants that directly affect human health. Regions surrounding mining sites frequently show elevated rates of respiratory illnesses and soil and water contamination. For a long time, these impacts were treated as necessary costs of progress. The dominant narrative claimed that economic growth justified collateral damage. However, as global environmental awareness increased, this logic began to be challenged. The central question shifted from how much can we extract to how much are we willing to lose. In this context, Bagger 293 became a powerful symbol, not only of humanity's ability to build massive machines, but also of its struggle to confront the consequences of those choices. Every meter the machine advanced represented not just coal extracted, but erased landscapes and interrupted histories. Over time, social pressure intensified. Environmental movements, civil organizations, and even government sectors began questioning the continuation of this model. Heavy mining, once considered an unquestionable economic pillar, increasingly came to be seen as a problematic legacy. Progress, once measured in tons and megawatts, started to be evaluated in terms of quality of life and sustainability. This shift in perception is essential to understanding why machines like Bagger 293, although still operational, have come to symbolize a past that the world is slowly trying to move beyond. The long operational lifespan of Bagger 293 cannot be explained solely by its technical efficiency or productive capacity. The real force sustaining its existence was economic and political. Machines of this scale do not survive in a free market without constant support. They rely on subsidies, state incentives, and government decisions that often ignore clear signs that the economic model they represent is reaching its limits. Lignite mining in Germany has always been deeply intertwined with the state. Coal was considered a strategic resource essential to national energy security. This justified massive public investments, regulatory protection, and in many cases, the artificial preservation of a sector that was already losing competitiveness. Bagger 293 thus became part of a system that needed to keep operating in order to justify the investments already made. This type of dependence creates a dangerous cycle. The more money invested in heavy infrastructure, the harder it becomes to abandon it. Governments face political, labor, and economic pressure to preserve jobs and prevent regional collapse. Shutting down operations means admitting that billions were spent on a model that no longer makes sense. As a result, outdated projects remain active, even when they are no longer economically or environmentally viable. The true costs of this system, however, rarely appear clearly to the public. Energy subsidies, environmental compensation, relocation programs, and infrastructure maintenance are spread across public budgets. The average citizen pays the price indirectly through taxes and long-term environmental damage, often without realizing they are financing the survival of a declining model. Meanwhile, new energy sources were becoming increasingly competitive. Solar, wind, and other alternatives began offering lower costs, greater flexibility, and reduced environmental impact. Even so, the transition was not immediate. Machines like Bagger 293 represent such enormous investments that their deactivation creates political and economic losses difficult to justify in the short term. In this scenario, the economy begins to revolve around maintaining the system itself rather than its actual usefulness. Coal continues to be produced not because it is the best option, but because the entire industrial and political apparatus depends on it. This phenomenon is known as the sunk cost trap, where past decisions prevent more rational choices in the present. Over time, this dependence became unsustainable. International pressure to reduce emissions, combined with falling renewable energy costs, exposed the fragility of the model. What once appeared as stability revealed itself as resistance to change. Bagger 293 kept digging, but its economic purpose was being questioned at every level. This part of the story is crucial because it shows that collapse does not happen suddenly. It is slow, silent, and often artificially prolonged by political decisions. The machine did not fail. What began to fail was the system that kept it relevant. No machine, no matter how large or impressive, exists outside the historical and economic context in which it was created. Bagger 293 began to lose its economic relevance, not due to technical failure, but because the world around it changed in profound and irreversible ways. Coal, once the backbone of industrialization, increasingly came under scrutiny as a foundation for the future of energy. By the late 20th century, the environmental costs associated with fossil fuels became impossible to ignore. Scientific research directly linked coal combustion to climate change, air pollution, and severe public health impacts. Pressure from civil society, combined with international emission reduction agreements, began to reshape energy priorities across many countries, including Germany. At the same time, technological progress dramatically reduced the cost of renewable energy. What was once seen as an expensive and limited alternative became economically competitive. Solar and wind power grew cheaper, faster to deploy, and most importantly, more flexible. Unlike mining megamachines, these systems could be scaled, adapted, and distributed according to demand. In this new environment, the rigidity of coal-based models became clear. Bagger 293 depended on specific mines, dedicated infrastructure, and a complex logistical chain. Every decision required years of planning and heavy investment. In contrast, solar and wind projects could be adjusted far more rapidly in response to market changes. Political cost was another decisive factor. Continuing to rely on coal meant facing international criticism, domestic pressure, and increasingly strict climate commitments. The narrative of energy progress began to shift. What had once been a source of industrial pride started to be seen as an obstacle to innovation and environmental responsibility. As a result, the symbolic value of Bagger 293 changed. It no longer represented efficiency and power, but a declining model. Its presence, once celebrated, became a constant reminder of decisions made in a different era under different assumptions. The machine kept operating, but its future was now discussed in terms of phase-out, transition, and legacy. It is important to note that this transition did not occur without resistance. Entire regions depended economically on mining. Workers, unions, and local communities feared unemployment and abandonment. The decline of coal was not just an energy issue, but a social one. In this context, Bagger 293 stood at the center of a complex debate about development, social justice, and the cost of change. What this phase of the story reveals is that large systems do not collapse all at once. They slowly lose relevance. They continue to function, but no longer point toward the future. Bagger 293 did not stop operating because it was inefficient, but because the world chose a different path. Over time, Bagger 293 ceased to be merely an operating machine and began to occupy a symbolic place in the industrial imagination. It became a moving monument to a specific era in human history, a time when economic growth was considered limitless and natural resources seemed infinite. Its overwhelming size, once a sign of progress, gradually came to represent excess. The machine was not immediately dismantled or abruptly abandoned. Instead, it continued operating through historical inertia. Large systems rarely stop all at once. They persist as the world changes around them until they become uncomfortable symbols of a past that no longer fits the present. Bagger 293 came to exist in this in-between state, functional yet questioned, impressive yet problematic. For engineers and historians, it represents the peak of technical capability applied without clear limits. From an engineering perspective, it is difficult not to admire its complexity and resilience. Every detail of the machine reflects an almost absolute confidence in the idea that problems can always be solved with more scale, more steel, and more energy. History, however, has shown that this logic carries a high cost. At the same time, for environmentalists and economists, Bagger 293 symbolizes delayed transition. It highlights how legacy systems can slow down necessary change. As long as giant machines remain active, financial, political, and human resources stay locked into a model that no longer points toward the future. The machine does not block change on its own, but it helps postpone it. This conflict of interpretations is what makes Bagger 293 such a powerful symbol. It is neither villain nor hero. It is a faithful product of its time. It was built with the best intentions, using the knowledge available and responding to the perceived needs of that era. The issue was not its creation, but the difficulty of accepting that the world had changed. In many ways, the story of Bagger 293 repeats itself across other industries. Massive infrastructures designed to last for decades collide with a world that evolves too quickly. When this happens, society faces difficult choices: cling to the past or invest in the future. Every year of delay makes the transition more expensive and socially complex. The machine then becomes more than industrial equipment. It becomes a mirror. It reflects human decisions, economic priorities, and cultural values. Bagger 293 shows that the true challenge is not building big things, but knowing when they no longer make sense. That is why, more than a structure of steel and gears, it has become a historical landmark, a silent reminder that not all progress is permanent and that the size of a project does not guarantee its relevance in the future. The story of Bagger 293 is not, at its core, a story about a single machine. It is a narrative about human choices, about how entire societies commit to certain visions of the future and often resist abandoning them even when the signs of change are unmistakable. Bagger 293 simply embodies this logic in steel, gears, and thousands of tons of displaced earth. For decades, industrial gigantism was treated as a synonym for progress. Building bigger meant thinking further ahead. Digging deeper meant securing economic stability. However, the case of Bagger 293 shows that size and longevity are not the same thing. A project can be technically flawless and still be economically fragile in a changing world. The true collapse associated with this machine was neither immediate nor dramatic. There was no explosion, catastrophic failure, or sudden abandonment. The collapse was silent. It occurred the moment the energy model that justified its existence began to lose relevance. The machine kept operating, but its purpose was slowly eroded by technological, environmental, and social shifts. This type of collapse is harder to recognize because it does not happen in a single event. It manifests through postponed decisions, investments maintained by inertia, and systems that remain active simply because they are too large to stop. Bagger 293 became the perfect symbol of this phenomenon, a colossal structure supported by a past that no longer provides answers for the future. Looking at this story, the question is not whether Bagger 293 was a mistake. The real question is how many current projects follow the same logic. How many infrastructures, technologies, and systems considered essential today may be viewed as problematic legacies in a few decades? Bagger 293 serves as a warning to any society that confuses scale with sustainability. Ultimately, the most important lesson is not found in the machine's engineering, but in humanity's ability to adapt. True progress is not clinging indefinitely to old solutions, but recognizing when it is time to change. Giant machines can move mountains, but they cannot change the direction of the world. Bagger 293 will remain in history not only as one of the largest machines ever built, but as a reminder that the future belongs to what can evolve. Size may impress, but adaptation is what truly endures.